Welcome to this video tutorial. In this video tutorials we will touch some of the things that we have learned during the different units of statistics too. So I recommend you to pause the video and read carefully the statement, and then after that I will develop the solution. Welcome to this video tutorial. In this video tutorials we will touch some of the things that we have learned during the different units of statistics too. So I recommend you to pause the video and read carefully the statement, and then after that I will develop the solution. In that case, we are interested in computing some probabilities in the environment of the distribution of the sample proportion. In that case, we know that the probability, so the parameter coming from population, of being born male is equal to 0.514. And the statement is what is the probability that in 1,000 births less men than women are observed. So we know that we are in front of a random experiment that is a dichotomous one. So we have a binomial with n repetitions and with parameter of success equal to p, and we know if n multiplied by p by 1 minus p is greater than 5, we can approximate this random variable that follows a binomial one by a normal distribution. In our case, we are in front of a binomial with 1,000 repetitions with probability of success 0.514. So if 1,000 multiplied by 0.514 multiplied by 1 minus 0.514 is greater than 5, in that case is equal to 249, we can approximate the random variable as a normal. Which kind of normal? The normal that has an expected value, the expected value of the binomial, np, and the variance of the binomial. So in terms of the standard deviation, will be equal to the square root of n multiplied by p by 1 minus p. But in fact, the sum of successes is not a proportion. We build the proportion as the sum of all these successes divided by n. And we know also by the properties of the normal that if we divide the normal by a constant, in that case the sample size, this is not going to affect to the normality of the distribution, but is going to affect to the parameters that characterize it. In that case, we will have a normal with expected value p and the standard deviation, the square root of n multiplied by 1 minus p divided by the sample size n. In our case, this proportion will be distributed as normal with expected value of 0.514 and the standard deviation, the square root of 0.514 multiplied by 1 minus 0.514 divided by 1,000, that is the sample size. If you do the computations, you will have a normal that is centered in the expected value of 0.514 and a standard deviation that will be 0.015805. But we are interested in computing what is the probability of being less men than women. So in that case, if the probability of success is equal to 0.514, so we are trying to analyze if the probability of the proportion is lower than 0.5, less men than women. So if we standardize in both parts of the expression, in the left side in terms of letters and in the right side in terms of numbers, we will have that we have in the left side p minus p divided by the square root of p1 minus p divided by n, and in the right side lower than or equal than 0.5 minus 0.514 divided by the standard deviation that is equal to 0.015805. So in fact we have the probability that in a normal 0, 1, the zeta value variable, what is the probability that the value of the variable is lower or equal than minus 0.896? So you know, as complementarity and you don't have the negative values in your statistical paper tables, so you have to arrange that, and this probability will be equal to 1 minus the probability of set lower or equal than 0.896. So the final result is that the probability is equal to 0.1878.